All right, what would you guys like to do?
Well, I went through, took me forever to go through bunch of stuff. And I got stuck on something. I mean, I don't know if you want to go through the whole thing, but it's number 9. I went through all the critical numbers and intervals and all of it. And then I get to where you find, and it's just simple algebra at this point, where not simple, but I'm not doing it right. Where is it? Or it was 8, wait, 8A at the end, 8A or yeah, where you at the inflection point. I don't know how you want to do this whole thing because
Is this from the study guide?
yes.
Okay. Okay. So are the inflection numbers correct? Is it just the sign chart that's off, or is it?
Well, I have the concave up and concave down correct. So
Okay.
you mean it's just plugging the x back into the original function I don't know what I'm doing wrong. I'm not getting the right answer.
Okay. What's the function?
The function is, it's a lot. Sorry, I have to find it on this page.
Oh.
P of x equals x squared plus 1 over x. Oh, no, that's B. Sorry. B 8. That's 9. Oh my gosh, sorry. I gotta get organized here. 3, page 3. Okay. No, it's 8 over x squared plus 4.
Is the x squared plus 4 all in the denominator?
Yeah. 8 over x squared plus 4.
Okay.
And I moved it up to the top to get a negative 1. So x squared plus 4 -1 times 8.
Okay. So you worked it all the way through, and so when you got your your inflection points from setting the second derivative equal to 0, I think, what did it do? I think it came out to, like, when you solve the top, it came out to like x squared is equal to 4 over 3.
So, okay, so I got from my first derivative, I got 16x over x squared plus 4 squared. Yeah. And then for my second derivative, I got 16 times 3x squared minus 4 over x squared was plus 4 to the third.
Yeah.
And then you set that to 0, you choose your number, or x equals 2 square root 3 over 3 plus minus,
Yes.
plus minus. So I went and I plugged, so plug into original formula to find y, to find my inflection point.
Yeah.
So I'm doing something wrong with the math here to get the inflection y. The inflection point y. I don't know what it is that I'm doing wrong.
Okay. So when you plug in that 2 root 3 over 3, like if you look at the step where it came from, it was from when you did, like, you had x squared equals 4/3. And when you square root it, that's where you get that 2 root 3 over 3. So when you plug it back into the original, you can go off of that original x squared that you had, that 4/3.
What 4/3? There's so much going on in this, it gets me really confused. So 4/3 is coming from what?
Well, you said earlier you had 3x squared minus 4. Right, that was part of your second derivative, and that's the part that's giving you a solution. Because the denominator is not giving you a solution at all, and neither is that 16 that was out in front.
Oh, x squared equals
4/3.
4/3.
And then you have to square root both sides.
Yeah. So
That's how you got your final values for x, that plus and minus 2 root 3 over 3. Right?
yeah.
So all you're doing is just going backwards because you have to plug it in for that x that's being squared, right? So if you take 2 root 3 over 3, if you
Oh.
square it, you're going to get 4/3.
Okay, I was going the long way with plugging f of x equals 8 over 2 square root 3 over 3 plus 4.
You can do that, but if you
I
do
mean,
it,
it's not
square it.
right. I'm not doing it right, whatever I'm doing. So I would rather just go the easier route and do the x squared equals 4/3 and just
Yeah.
put that in instead. Okay.
If you squared 2 root 3 over 3,
You have to square everything, right? You have to square the 2 squared, 3 square root or square root 3. Yeah, that's what I did.
so then the 3 goes into the 9 3 times.
Oh, I must have been doing, oh, I square rooted the denominator too.
Oh. You
Wait, I
square
did,
rooted
no,
the
that's right. That's right.
two.
I don't know. I've
Well,
worked
you
on
would have gotten 12/9, which is 4/3.
12. I think I was, oh, you know what? I didn't put the square in there. I was trying to add 2 square root 3 over 3 to plus 4. That's what I was doing. Okay. All right, let's just do that instead. The 4. Okay. So the
Okay, so then
4/3 instead
yeah.
of x squared plus 4. Running
So
out.
then 4/3 plus 4 would be 16 over 3.
And pencil.
So then you multiply by your reciprocal. And we end up with 3 all over 2. And you'll get the same answer whether you plugged in the positive or the negative x value, because you're squaring it. Oops.
Yeah.
So because you're squaring it, you're going to get a positive no matter what. So it's going to give you the same result. And there's your 2 inflection points.
9 times 3. Okay. So 16/3. Yeah. Oh, that's what I did. Okay. Mm. 2 plus
else do you guys want to do or talk about or go over, discuss?
Um, Number 12, I was having trouble with it. And I don't understand the question.
Okay, can I clear this thing?
Yeah. Yeah.
Okay. Number 12.
Yeah. Determine if the graph values are positive or negative.
Oh, do I need to see it?
It's the graph given is on the study guide.
Okay, let me pull that up. Oops. Okay, number 12. All right, so using the graph of f drawn below, determine if the given values are positive or negative. And probably should not have had a question mark, but that's okay. All right, so 12a, f double prime of -3. Okay, so when they're talking about the second derivative, what thing are they talking about? Or like, what thing does the second derivative go with, I guess?
Well, I thought it was always positive or concaving upward. Is that wrong?
Concavity, yeah. So in this, if you look at the graph, at that point, my best to draw this. Oh, no. Okay. So -3 was about there. So is that graph concave up or concave down? At that particular point.
It is concaving up.
It's concave up. So would the second derivative be positive for concave up or negative?
I guess it'd be negative because it's a -3.
It's, well, concave up means it's the second derivative is positive. So for A, it's positive. If it was concave down, then the second derivative would be negative.
But I thought I don't know if this rule, I'm getting it wrong or something, but it's always concave up, the second derivative.
The second derivative can, what do you mean by always concave up?
I think I'm taking things a little too literal. Never mind.
Okay. So if you look at the graph, like just in that little area, that graph is concave up, which means the sign of the second derivative has to come out as a positive. So if you would have done like a sign chart, you know, to test your concavity.
Mhm.
Oops. There we go. You know, you'd have your numbers in there, like you'd be testing like -1 and I don't know, 4. You have your test numbers and it's coming out positive and then negative and positive, just for example. So anytime you had a plus sign, that meant it was concave up, right?
Mhm.
So if it's concave up, that means the second derivative had to be positive. Just like if it's a minus, you know, it's concave down.
Okay.
So if you know it's concave down, that means the second derivative has to be negative, and so on and so forth. So for part B,
Could I answer that with just saying positive on a test instead of greater than?
yeah,
Okay.
yeah, because I just made it sign chart just in general. Because I don't know, we don't have enough information to make one for this graph. I was just trying to link together the concept.
Okay.
And that's all it's asking is if it's positive or negative. So that's all you have to say.
So B is a positive or negative. At 1, it's concaving down, so it's negative.
There you go. And then for C,
We got 8 that's going up.
so that means it's,
Positive.
yeah. Oops.
Okay, that was simpler than I was thinking. Okay, so for 13, I don't know if anybody wants to jump in, but I could keep going. Yeah, 13 sounds good. I don't know what I did wrong there, but I did something wrong.
Okay, let's see. Oops. Trying to scroll the page. Okay, so 13, find the dimensions of the rectangle of the largest area which can be inscribed in the region bounded by the x-axis and the y-axis. Okay, in the graph of y equals 8 minus x to the third. Okay, so let's get a little visual aid. So 8 minus x to the third, it's doing something like that. So it's hitting the y-axis at 8. And then it's hitting the x-axis at 2. So the rectangle that they're going to draw in there is bounded by this curve, the y-axis and the x-axis. And it's hitting that curve anywhere on there, and we don't know where it is. So the only thing you can do is just label it as x and y. Okay, so let's get our primary equation. So the primary equation is whatever you're trying to, maximize or minimize. So what is it that we're trying to find the maximum or the minimum of?
Rectangle.
But what of the rectangle? Is
Okay.
it the perimeter, the
Area.
area? Okay, so that means we're working with an area equation. So the area of that rectangle is just going to be x and y. So then your secondary That's usually whatever you're kind of given in the problem. Or something that might have some value that they gave. So like if it's a fencing problem, they'll tell you the perimeter or something like that. But for this one, the only thing they gave you was the curve. Your y equals 8 minus x to the third. So typically you take your secondary equation and you solve it for either x or y or whatever variables are in there. And it's usually your choice. Like it doesn't matter which one you go for, you just have to pick one. This one, they already did it for you, so you might as well use what they have. So we'll just take the y and plug it into the area. So then it's just x times 8 minus x to the third. And then I would just expand it out. So 8x minus 8x to the fourth. And now that it's all in terms of x, then you can get your derivative. Should be 8 minus 32 x to the third. And then once we get our derivative, what do we do with it?
Why is it 8x minus 8x to the fourth?
Oh, I don't know. It just, apparently I just like the number 8. Yeah, that should just be x.
My derivative is x minus 4. X minus 4 to the
Yeah,
x minus x 4x to wait.
yeah, 8 minus 4x to the third.
And then I got x times 1 minus 4x squared.
So once you have your derivative, then set it to 0. So x to the third equals 2. So the x is the cube root of 2. So that's your x value, but they wanted the dimensions. So you need the base of it, which we have, but then they also want the height. So then you go to the equation for y. And stick in the x value that you just found. So your y value comes out as 6. So just be sure you're finding whatever it is that they want. So sometimes they'll ask for the dimensions, so you need to give 2 answers, your x and y. Sometimes they just want the area. which means your answer is only one number. Just kind of depends on what they want.
So the width is X and the Y is the height. Okay.
Yeah. Okay, let's see. Can I clear the board?
Sure.
Okay. I have a question for you guys. Let's say it was just like where is f of x equal to x to the fourth increasing. So typically if it asks you where a function is increasing, what do you normally do?
Are you looking at a graph? Or are you drawing out your graph first?
Not usually. Usually you would go off of the derivatives,
Okay.
right? Because that's normally, I mean, that's kind of what we've been doing for just about all of them. However, for this one, you did guess correctly. I would actually graph it. So the graph looks like that, and it does hit the origin. I just missed with my mouse. So if you looked at the graph, then it would be a lot easier.
Would it be not including 0?
Right, your intervals of increasing, decreasing, and as well as concavity, they're always open. So it'd be increasing from 0 to infinity. Now, if it asks for the analytics, like analyze and find your intervals of increasing, decreasing, and all that sort of stuff, then you do have to go through your derivatives and stuff. Especially on a free response type question, you got to show what you're doing. Wow. Well, I think I'm gonna have to. That's weird. I just got a notice saying that Zoom's gonna shut this meeting off in 10 minutes. Because apparently I'm not or logged into the right thing. So if it does shut off, I'll just start another one, and I'll put another announcement with the link in there. So just don't panic if it just shuts off. That's weird. It's never done that before. Ugh, fun times. Okay, what else do you guys have? Would like to talk about?
15.
Okay, let f be a function defined and continuous on the closed interval from a to b. If f has a relative maximum at c, and c is somewhere in the interval, which of the following statements must be true? Okay, so first one, f prime of c exists. Okay, so do you think that's true or is it false? This can be, it's not just for Brianna, it's for the entire class. Well, it's a 50-50, so even if you don't know, you could still guess at it. It's either true or it's false. Okay, Ryan says it's true. This one's actually false. Because when you're looking for relative extrema, so relative max, relative min, those are coming from your critical numbers, which means that the derivative could be 0 or it could be undefined. So just because you have a relative max doesn't mean that the derivative has to exist, because it's either 0 or d and e, one of the two. And there are functions where that happens. So if you think of absolute value or a graph like this, both of those have a sharp point at their relative max, which means that those derivatives are d and e, they don't exist. So the first one's false because you could have either of those two cases. Okay, the second one, if the derivative exists, then the derivative would have to equal 0. So what do you guys think about that one? Do you think it's true or false? Yeah, that one is true, because now you know that the derivative exists there, so it can't be d and e. So then it has to be your only other option, which is 0. Okay, and then the third one, if the second derivative exists, then the value of the second derivative is less than or equal to 0. So I think that's true or false. This one's actually going to be true. Okay, so you've got your relative max. Right there. So for a maximum to occur like this, they're talking about the second derivative, and the second derivative goes with concavity. So is this concave up or concave down?
Down.
Which way?
Down.
It's concave down, which means the second derivative has to be, what, is it positive or would it be negative?
Negative.
It's negative. So then the other part of the thing in there is that equal bar. Well, there are functions where your where your second derivative would actually equal 0, but it's not necessarily an inflection point. It's like f is equal to x to the fourth. It's like your first derivative would be 4x to the third. And your second derivative would be 12x squared. But if you solved it for 0, you would just get 0. But if you ran through it and you tested it, oops. It comes out positive. So that would be a case like this. Like your concave or your inflection point, or sorry, your concavity doesn't have to necessarily switch. Sometimes it just equals 0 there. So the equal bar is also allowed. So choices 2 and 3 are valid. They're the true statements, but not the first one.
Do 16.
We probably could. All right, the maximum acceleration attained on the interval from 0 to 3 by the particle whose velocity is given by that is what? Okay, so if you are given any function, how do you find the maximum or the minimum of it? Like, what's the process you have to go through?
Derivatives.
You find its derivative and then you set it equal to 0, get the critical numbers, and so on and so forth. So yeah, first derivative test. Okay, so what are you trying to find the maximum of?
Acceleration.
Acceleration. Do you have acceleration?
It's on the interval.
But did they tell you, hey, this is your acceleration function?
Given by the VT.
So did they give you acceleration?